Hi, welcome back again. So today we are going to talk about Advs, vital signs. So Adam vital signs, okay, it works similar like basic data structure. When you check the classification here, so this is also it comes in the basic data structures, and it will be having one or more records per subject, per analysis parameter, and per analysis time point. It will be the similar structure how we have in the laboratory data. So most of the stuff will be having the same similar pattern. So let's continue with this programming. Okay, here we have the header part. It will be the same thing. So we'll be using the VS as a white HDTM as a source data set, and we're also using Adam ADSL. Then the final output will be having Adam VS data set. Okay. So this syntax rm list ls is removing all the datasets, whatever the datasets we have it previously, we are removing those ones. And then we are calling all the required libraries in order to execute this program. Okay, that ID was deploy libredate admiral. Make sure you should have to be installed in your RStudio before you start doing these functions. Otherwise, this function it won't works, because if you don't install these packages, it won't works the RStudio. Okay, next we have setting working directory, and we check the what is the working directory we have in our clinical course. Then we take the raw data, source data SDTM and Adam, and then we're reading that required SDTM dataset VS and ADSL as well. Okay, so once we got all the required the datasets, then we combine both ADSL and VS. Since a study ID in have both of them in datasets, I'm dropping ADSL for study ID from the ADSL, not to get any conflict at the end. Okay, so VS ADSL combined together with left join by unique subject ID. So the VS2 will be having almost like 53 variables and 1760 observations. Thereafter, we'll be continue with the VS2. VS3 is a new dataset name, and VS2 is this one, the dataset. And mutate is function if you need to create more variables, new variables, and if you want to modify existing variables, you can use mutate function from the deploy package. So a visit, nothing but visit. So when you check the specification here, so here as well in the ADVS, we'll be having the predecessor and derive. So most of them are coming from the ADSL, and some of them are coming from the vital signs as well. So we get directly from here, and we don't need a predecessor at the moment. So I'm just filtering out that part, and we have only few variables to derive. Okay. So first one is a visit is directly we map to the visit here. Here visit from the vital signs, then a visit n analysis visit in the numeric format we giving as a visit num in SDTM VS. Then ATPT is a time point of analysis time point, then we give it out to vital signs time point, and the numeric format we have giving the visit num. Okay, visit num time point. So the param will be the same thing how we did in the laboratory data set. So here we have visit combination of the VS test and VS original unit. When you check param, it's a combination of VS test and VS original unit. So we have to do on the same thing. So paste 0 concatenate function of VS test, and the bracket will be having the VS standard result unit, not original units. It should be standard result unit. Then the param CD, this is VS test CD. Here assign VS test CD. So this one is in the bracket VS test RE VS standard test results. Okay, I'm sorry, units. Okay, so then when we have carom cd, when a param cd is a height equal to 1 and weight equal to 2, BMI equal to 3 pp. So you need to check what is the param cd, how many we have. So just go here and put check condition here, put unique, then vs2 dollar symbol, and vital signs test. When you execute, you'll be having the values here. So you will be having BMI, height, weight, dia, BP, pulse, PP, and temp. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So there are 7 parameters. Okay, so we give the right amount of number for that param numeric format. Okay, so let's continue with this one. So we have VS3 here. So when you check VS3, so we have param CD and the param in the numeric format. So we have BMI 3, height is 1, weight is 1. So we're giving the numbers for that, for those parameters in the numeric format. Okay, then we sort as per this, as per each record has it by has a number of records, right? Each subject has a number of records by parameters, by time point wise. So because since we also have a time point, not only the days, we also have the time points. We are sorting based on the date, time point, and the day or visit wise, and by parameters. Okay, we are sorting like this order. Then we're giving that VS standardize numeric part 1. If else, if VS standardize standard result numeric in, if it is NA missing, then we're giving as a this one, else we're giving as VS STR standardized unit. So there should be no NA missing or dot. If there is a thing, we consider as NA, otherwise we consider as a VS standardized result unit. Okay, so the next one is Aval. Aval has given the standardized test result unit. So when you check here, original unit, numeric version of the original unit, but we always consider the standard result unit. So aval is the numeric part of standardized, because here is n1 because we haven't converted the character format. Okay, so let me PS3 here. So it is in the character format. Okay, so the VS n1 we're changing into numeric format. Then for the character we give it to directly to the VS standardized test results here. The numeric result standard units, or numeric result standard units. Then we, for the units also, the VS standardized result units, we give eval u. So same pattern how we did in the laboratory dataset. For baseline value, if ATPT equal to 0, then we consider as a y, and the remaining we give it as missing. When you have when you check ATPT, because this one is giving as based on the time point as well, right? Not only visit, it is giving in the time point. Okay, so we have check-in 0.2.8, then checkout for each individual variable. Okay, there's a truncation, but it's okay. Here is, so for each parameter we'll be having a check-in 0, then checkout 2, 8, and checkout. So for baseline value, considering baseline value the baseline value PLF, considering the flag here 0 time point, consider as a assign a flag here 0 time point. So when you have the ATPT is equal to 0, then we consider as a y, else missing. Okay, okay, so the next is a base variable. The base variable, if analysis baseline flag equal to y, then we give it as the value aval value to the base, else missing. Okay, if there is nothing, which means it's missing. Okay, then we do shift variable. Shift variable is nothing but base. So when you go check aval value here, so as per the specification, when you check here, so the shift is considered baseline value to the refers to the baseline value refers to the last result prior to administration of the first dose of the study medication. It is the similar how we derive for the base value. So base will be also the same thing, last measurement made prior to administration of the first dose of the study medication. So thus then there is no difference what is the base and shift, it will be the same. So shift 1 equal to base. Okay, next it's change. The change is It is the same how we derive in the laboratory data set. If there is no missing value in the base and a wall, then we give it a wall minus base. As per the specification, there is a derivation directly has given a wall minus base. Okay, and the percentage change as well. If there is no missing values on the base and a wall, and the base not equal to 0, then we give it a wall minus base by base into 100, else is missing. Okay, so quite simple formula to do it. Then we come to the treatment plan and treatment actuals. So if a visit equal to period 1, then we give it as a treatment 01p, and if it a visit equal to period 2, then we give it as a treatment 02p, and else we will give it as missing in a character format. When it comes to the numeric, if it is period 1, then we give it as a treatment 01p numeric format. In a visit equal to period 2, then we give it as a treatment 02pm, and if it is missing, we give it as a missing in integer format. And the actual one also will be the same, so there is no difference on it. Then we come to the handling the date conversions. In date conversions, ADT. So ADT is basically you considering the date format. As dot date is taking only the date format. We're not considering the time point, and we are applying because if the length of the VSDT is greater than or equal to 10, then we have giving this 1 into 10, which is only the date format, and in the format of year, month, and date. Else we're giving as a missing for the analysis date, and analysis date and time we are directly mapped to assigned to VSDT. Okay, then anal 01 flag, if a wall is not equal to missing, then we give it as a Y, else we give it as a NA. It is also the same thing how we did in the laboratory dataset. And a period C also, if the a visit n in the 0 1, then we give it as a period 1, and a visit n equal to 2, more than 2, more than equal to 2, then we give it as a period 2, else we give it as a missing character. And here if this is a period is a numeric format. If the average is in 0 1, then we give it as 1, else we give it as a 2. Okay, so once we derive all the required variables as per the specification, so we have analysis change, most of them we have done, ATPT numeric format. So we select all the required variables. Let's run this one. Since because the other variables apart from the derive, so the predation variance is already be created in ADSL and the VS dataset. So these automatically will come from the HDTM dataset as well as from Adam dataset. Okay, then we apply the labels for those variables. Then we have to call H miscellaneous. Make sure you don't have at the end comma. If you have a comma for like individual, you see comma there, but then at the end you don't keep the comma, because if you have a comma, it won't run. So here as well, there should be no comma at the end of the variable. Okay, so then we call the package. Then we update the labels to those variables. The final data set here. Data set here. Okay, then we save it as an RDS format. So our dataset format. Okay, so when you go here, you'll be having this part X, save it here. Okay, hope you guys understand this part. This is a quite simple programming. If you know a laboratory data set, because most of this BDS data structure will be having the same pattern. You will be having the param cd, eval, base, change, percentage change, and some anal 01 flag, analysis date, and treatment information. So if you know these derivations easy, and it is easier to do the BDS data structure. So that's it for today. Thank you so much. We'll continue for another class for the TLF part. Okay, thank you for listening.